Hi there, welcome to this lesson on Pure Mathematics 3, and in this lesson we're looking at what's called the harmonic form. Now the harmonic form refers to trigonometric expressions. In recent lessons we've been looking at the addition formulae, and one thing that you can do with the addition formulae is to simplify expressions that have the form some multiple of sine x plus or minus some multiple of cos x. So for example, something like 3 sine x minus 4 cos x. And it allows you to join the two functions together into one function of sine x or one function of cos x. We'll be using the addition formulae. Normally in these questions they tell you which one you have to use, but they don't have to. Sometimes you'll need to go back to the addition formula yourself and decide which is the right one to use. What we'll do is we'll go through an example together because it's quite hard to guess your way through these questions. And we'll look at the general form. So normally you'll be given some specific number of sine theta, some specific number of cos theta. But we'll look at the general form where you're not told the numbers and you've just got a sine theta plus b cos theta. And we've been asked to write it in the form r sine theta plus alpha. Normally you'll be told this. You'll be told what form to write it in. But as I say, it's possible you won't be, in which case you'd have to choose one of the addition formulae yourselves. You'll also notice that it says where r is greater than 0 and alpha is between 0 and 90 degrees. You don't need to worry too much about that. Those conditions apply to all of these questions. We take r to be a positive value and alpha to be in that range. But that happens automatically without you having to think about it. We start just by writing down the two expressions we have, a sine theta plus b cos theta, and we say, well, let it be equal to r sine theta plus alpha. The goal of the question is to find the value of r and the value of alpha. So that's what this is working towards, how you can work out exactly what number r is and exactly what angle alpha is. First thing we do is, yes, use the addition formulae to expand sine theta plus alpha. And that'll give you r sine theta cos alpha plus cos theta sine alpha. And the next thing is the crucial step. We equate the coefficients of sine theta and cos theta. So we've got a sine theta on the left-hand side and r cos alpha times sine theta on the right-hand side. B cos theta on the left, r sine alpha times cos theta on the right. And what that means when we equate the coefficients is that a must equal r cos alpha and b must equal r sine alpha. To work out the values of r and alpha, we use Pythagoras to work out the value of r, and we use trigonometry to work out the value of alpha. Using Pythagoras, what we do is we square the two equations and we add them together. So we do 1 squared plus 2 squared. And on the left-hand side, that'll give us a squared plus b squared. On the right-hand side, it'll give us r squared cos squared alpha plus r squared sine squared alpha. We then factorize this, and that factorizes into r squared into cos squared alpha plus sine squared alpha. And then we say that cos squared plus sine squared is equal to 1. So this whole thing simplifies to a squared plus b squared is just equal to r squared. To find r, we need to square root the left-hand side. So we find the square root of a squared plus b squared. And that's always the method we use. These questions don't change. Once you've learned the method and got used to the method, the questions are always the same in the exam, and you can just use the method confidently. To find alpha, we use trigonometry. And what we do is we divide the second equation by the first equation. So we do 2 divided by 1, which on the left-hand side gives us b divided by a, and on the right-hand side gives us r sine alpha divided by r cos alpha. R divided by r is 1, and sine alpha divided by cos alpha is tan alpha. So that simplifies to b divided by a is equal to tan alpha. And then to find alpha, all we have to do is inverse tangent of b divided by a. Okay, I'll let you have a go at doing one of these yourself first. So in this case, we've been told the values. A is 4 and B is 3. So we're writing 4 sine theta plus 3 cos theta. And this time it's in the form r sine theta plus alpha. So again, we've got the addition formula for sine a plus b up here. We'll be using that just as before. I'll let you have a go, pause the video, and come back to me when you're ready. Okay, we'll have a look at this, and we use exactly the same method as we did on the previous example. So we begin just by saying that 4 sine theta plus 3 cos theta is equal to r sine theta plus alpha. We then expand this using the addition formula, and that gives us r into sine theta cos alpha plus cos theta sine alpha. We then equate the coefficients of sine theta and cos theta. On the left-hand side, the coefficient is 4. On the right-hand side, the coefficient is r cos alpha. And for cos theta, on the left-hand side, the coefficient is 3. And on the right-hand side, it's r sine alpha. So equating the coefficients gives us these two equations. 4 equals r cos alpha, 3 equals r sine alpha. To find r, we use Pythagoras, which means we square the two equations and add them together. 1 squared plus 2 squared. On the left-hand side, that gives us 4 squared plus 3 squared. On the right-hand side, it gives us r squared cos squared alpha plus r squared sine squared alpha, which we factorize to get r squared into cos squared alpha plus sine squared alpha. Cos squared plus sine squared is 1, so that means that 4 squared plus 3 squared is just equal to r squared. To find r, we square root the left-hand side, and the square root of 4 squared plus 3 squared is the square root of 25, which is 5. And we've been told r is greater than 0. We always just take the positive value. R is plus 5. To find alpha, we use a little bit of trigonometry. We divide the second equation by the first one. 2 divided by 1 gives us 3 divided by 4 on the left-hand side, and r sine alpha divided by r cos alpha on the right-hand side, which again simplifies to tan alpha. To find alpha, we do inverse tangent of 3 divided by 4, and that gives us 36.9 degrees. We found r, we found alpha. R is 5, alpha is 36.9. We can now substitute those values into this expression to get the answer, which is that 4 sine theta plus 3 cos theta is equal to 5 sine theta plus 36.9 degrees. Okay, example 2. Part 1 is exactly the same as what we were doing just now, except we've changed from using sine A plus B to sine A minus B. And then part 2 asks us to draw a sketch of this using our answer. I'll let you have a go yourself first. Pause the video, come back to me when you're ready. Okay, we'll have a look at part 1 first of all. This time we're using r sine x minus alpha. So when we expand the right-hand side, we'll get r sine x cos alpha minus r cos x sine alpha. Equating the coefficient of sine x will give us 1 equals r cos alpha, and equating the coefficient of cos x, we get root 3 is equal to r sine alpha. Squaring and adding gives us 4 is equal to r squared. Square rooting the 4 gives us r is equal to plus 2. Doing 2 divided by 1 gives us root 3 divided by 1 is equal to tan alpha, and inverse tan of root 3 is 60 degrees. So we found r is 2, we found alpha is 60 degrees. We can substitute those in, and we get the answer that sine x minus root 3 cos x is exactly the same as 2 sine x minus 60 degrees. Now, part 2 of the question asks us to sketch the original function. Well, the way we'll sketch this is by sketching the answer that we just got, which we know is the same as that, because it is so much easier to sketch the right-hand side than it is the left-hand side. To sketch 2 sine x minus 60, I wouldn't try and get there in one go. I get there in stages. First of all, do a very quick sketch of sine x. And sine x looks like that, going from 0, crossing point at 180 and 360. And then do the sine of x minus 60 degrees. So that's a transformation where we're taking away 60 degrees from the x values, And I hope you remember what that means is we actually move the graph to the right-hand side, moves in the opposite direction from what you expect when you change the x values. So the whole graph will shift 60 degrees to the right-hand side, which gives us that. Then we'll worry about the 2. So we actually want 2 times by the sine of x minus 60. That's just a stretch with scale factor 2 in the y direction. So instead of going up to 1 and down to -1, those distances will be doubled. And the graph will go up to 2 and down to -2. It doesn't affect the crossing points on the x-axis. Those will stay the same. And that's the answer. Okay, example 3. Express 3 cos theta minus 4 sine theta in the form r cos theta plus alpha. You'll need to check yourself what the addition formula is for cos A plus B. And then we're asked to solve the equation 3 cos theta minus 4 sine theta equals 1. And again, we'll use our answer to part 1 to do that. Have a go yourself, pause the video, come back to me when you're ready. Okay, part 1 we'll do first. And we need the addition formula for cos theta plus alpha this time. Well, the addition formula for cos theta plus alpha, or cos A plus B, is that we get cos A cos B minus sine A sine B. So when it's theta and alpha, it's cos theta cos alpha minus sine theta sine alpha. From then on, the method is exactly the same. So equating the coefficient of cos theta, we get 3 equals r cos alpha. Equating the coefficient of sine theta, we get 4 equals r sine alpha. We use Pythagoras to find r, squaring and adding. Again, we've got 3 squared plus 4 squared, so we'll get 25 is r squared, and r is equal to 5. We'll do 2 divided by 1 to find alpha. 4 divided by 3 is tan alpha. Inverse tan of 4 divided by 3 is 0.9273 radians. And can't remember, the question makes it clear you're working in radians. I say it makes it clear. We're told that alpha is given in the range 0 to pi by 2. So the moment you see that, that is the moment when you should realize, oh, okay, this question isn't working in degrees, it is working in radians. And that's what alpha will be in radians. We can now write down 3 cos theta minus 4 sine theta is equal to 5, the value of r we calculated, cos theta plus 0.927 radians. Okay, part 2 asks us to solve the equation 3 cos theta minus 4 sine theta equals 1. And again, the range is in radians. Theta is from 0 up to 2 pi. Well, we just worked out that 3 cos theta minus 4 sine theta is equal to 5 cos theta plus 0.927 radians. So that is the equation that we will solve. 5 cos theta plus 0.927 equals 1, because it is much, much easier to solve than what we would be solving if we tried to solve the left-hand side. First thing we do is need to move the 5 across, and that gives us cos theta plus 0.927 is 0.2. Then we'll do inverse cos. Inverse cos gives us theta plus 0.927 is 1.3694 radians. Now, at this point, we need to find other solutions in the range 0 to 360 degrees or 0 to 2 pi. You do that the moment you do inverse cos. If you're ever confused as to when you need to find the extra solutions, it's the very first thing you do after you've done inverse sine, inverse cos, or inverse tan. You immediately find the other solutions. So that's the one we found already, which is at 0.2, 1.37. In the range 0 to 2 pi, there'll be one more solution, which is there. And to find that, I'd use the symmetry of the curve. So 2 pi take away 1.37, and that gives us 4.91. So those are the two solutions in the range that we wanted, which means theta plus 0.927 either equals 1.3694 or 4.9137. We still need to take away the 0.927, so we'll do that. And that gives us the final answer for theta. Theta either equals 0.442 or theta equals 3.99 radians. Okay, example 4. Example 4 says, given f of theta is equal to 8 plus 5 cos theta plus 3 sine theta, find the greatest and least values of f of theta, and in degrees, find the smallest positive value of theta for which each occurs. Now, you're not given much guidance in this question. You will be writing the thing in harmonic form. If you're wanting to do it the same as me so you can check it through, I'll be using cos A minus B when I do it. You begin by ignoring the 8. So you just discard the 8 completely and look at 5 cos theta plus 3 sine theta exactly as we have done on the previous examples. But I'll let you have a go yourself first. If you can make sense of it, have a go. Pause the video, come back to me when you're ready. Okay, let's have a look at this. As I said, the first thing is not to worry too much about the 8. 8 is a fixed constant. That means it doesn't change. It's not a variable. And if we're finding the greatest and least values of that function, we can ignore 8 because it's always 8. We'll always be adding it on. So what we actually need to do is find the maximum and minimum values of 5 cos theta plus 3 sine theta. And the way we'll do that is by rewriting that function in harmonic form. So I'm using cos A minus B. I don't think you had to use that. Sometimes you have a choice with these things, but I'll choose to use cos A minus B. And that gives me 5 cos theta plus 3 sine theta is equal to r cos theta minus alpha. Expanding that using the addition formula for cos A minus B gives us r cos theta cos alpha plus r sine theta sine alpha. Equating the coefficients of cos theta and sine theta gives us 2 equations. 5 equals r cos alpha and 3 equals r sine alpha, exactly as in the previous examples. We use Pythagoras to find r. 1 squared plus 2 squared is 5 squared plus 3 squared. 25 plus 9 is 34. So 34 is equal to r squared, and r will equal root 34, which I'll just leave as that, rather than write it as a decimal. To find alpha, we use trigonometry. Doing the second equation divided by the first one gives us 3/5 is equal to tan alpha, which means alpha is inverse tangent of 3/5, which is 30.96 degrees. So we found r, we found alpha. We can now say that 5 cos theta plus 3 sine theta is equal to root 34 cos theta minus 30.96 degrees. Now that gets us to the second part of the question. And the second part of the question asks us to find the greatest and least values of this function, which also includes 8 in degrees, and find the smallest positive value, in degrees of theta, for which each of these occurs. Well, what I've written there is what we've done already, that 5 cos theta plus 3 sine theta in harmonic form is equal to root 34 times by the cosine of theta minus 30.96 degrees. Now, it's surprisingly easy to find the greatest and least values of this function on the right-hand side. And that is because we know the greatest and least values of cos or sine. They never ever change. The greatest value of cos is always 1. The least value of cos is always minus 1. So that means the maximum value of cos theta minus 30.96 is plus 1. It can't be bigger than that because that's the maximum value of the cosine of anything. That means the maximum value of root 34 times by the cosine of theta minus 30.96 is root 34 times 1, which is just root 34. At this point, we finally say, but there was 8 we needed to add on as well. But you really don't need to worry about it until this point. So the maximum value of 8 plus root 34 cosine theta minus 30.96 will just be 8 more than that. We're just adding on 8. So that's the maximum value of the function f of theta, 8 plus root 34. And we do something very similar for the minimum value. The minimum value of cos is always minus 1, so it doesn't matter what we've got in the brackets here. The minimum value of that function will be minus 1. That means the minimum value of root 34 times by it will be minus root 34. And the minimum value of the function that we've actually got, where we have to add on 8, will be that value plus 8. So minus root 34 plus 8, or 8 take away root 34. But that's the answer to the first thing they've asked us, the greatest and least value of f of theta. The maximum value of the function is 8 plus root 34, and the minimum value of the function is 8 minus root 34. We were also asked to find in degrees the smallest positive value of theta for which each of these occurred. Now the maximum value occurred when cos was equal to 1. So cos theta minus 30.96 is equal to 1. We just do inverse cosine and solve this in the normal way. And that'll give us theta minus 30.96, inverse cosine of 1 is 0. And rearranging that gives us theta equals 30.96. And that is the smallest positive value of theta, which is a solution to that equation. We don't need to look any further. The minimum value occurred when cos was equal to minus 1, and we just do exactly the same thing again. Find inverse cosine of both sides, and that gives us theta minus 30.96 is equal to 180 degrees. Inverse cosine of minus 1 is 180. Adding on the 30.96 gives us theta equals 210.96. And again, that is the smallest positive value of theta, which is a solution to that equation. Could do a sketch at this point just to check, but that is the smallest positive value. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 79 and have a go at exercise 4D. Thank you very much for listening, and cheerio.